Assalamualaikum warahmatullahi wabarakatuh. My name is Nadzatul Nabila binti NAZLAN, and today I would like to present about magnetic field line on bar magnet. For objective, first one, to understand the effects of the magnetic field line on the charged particles. The second one, to observe the magnetic field line around the bar magnet using ion fillings. Introduction. The magnetic field is the area in which there is a magnetic force around a magnet. Magnetic fields can be created by moving electric charge. Magnetic flux line can be used to depict magnetic field. The magnetic field's direction is always indicated by the direction of the magnetic flux line. The intervals between the magnetic flux line determine a magnet strength. The stronger the magnet is, the closer the flux lines are to each other. The weaker they become, the further away they are. Placing ion fillings over a magnet will reveal the flux line. The ion fillings travel about and form lines. Other particles that encounter magnetic fields gain power. The magnetic field is a non-physical concept that defines the influence of magnetic force in each area. Magnetic field lines are a type of visual representation of magnetic fields. Next, for results. From this experiment, the figure above shows the magnetic field line on a single bar of magnet. The ion filling shifts onto the magnetic field line. When the magnetic field is strong, the field lines are crowded together, surround the magnet. Meanwhile, when they expand out further away, the magnetic field is weak and become less dense. So this is the area where the magnetic field is weak, and this is the area where the magnetic field is strong. Next, this based on the figure above, when the magnet bars are placed with the same pole on the paper facing each other, the ion fillings move away from each other at space in between of the space in the middle of the magnets, which we cannot see from here. The magnetic field is strongest inside the magnetic substance, as seen by the magnetic field lines. Near the poles, the strongest external magnetic fields exist. A magnetic north pole will attract another magnetic south pole while repelling a north pole. So for this one, the magnets are using with the same pole, which is the north pole. So that's why it's repelling each other. And this is the magnetic fields for the two bars magnets with the same poles. The last one, in figure above, shows two magnetic bars with different poles on the paper. The iron filings become thicker at the space in the middle because when the magnetic field lines between the poles become denser as they approach each other, and the magnets experience an attractive force. This is because this is opposite poles. These two magnets are opposite poles to each other, and so they are attracted to each other. They experience an attractive force here. So, around here is the magnetic field stronger. So for discussion, the field lines are dense around a bar magnet, representing the high field intensity near the poles. Field lines become less thick as we zoom out from the poles, indicating a reduction in field strength. All field lines start at the North Pole and end at the South Pole as well. The field lines cannot cross because they indicate particle loads. Otherwise, a particle starting from the point of crossing will have unclear dynamics. The magnetic field line will bend away from each other, causing repulsion if using the same pole of magnetic bar. Because the magnetic field density is nearly zero between the two north poles, the magnetic field is relatively feeble. If we ignore the Earth magnetic field, a compass placed at that location will essentially spin freely, non-stop. The magnetic field lines between the North and South Pole, on the other hand, are quite dense, indicating a very strong magnetic field in this region. A compass position here will soon align with the magnetic field and point to the right South Pole. Lastly, to get an accurate result of the magnetic field line, the iron filings need to be poured in large quantities so that the field line can be obtained clearly. Lastly, for conclusion, as a conclusion, the observation of magnetic field towards the moving particles are achieved because this can be proven through this experiment where the iron filings are moved around the magnet when the iron filings were poured onto the paper. Next, the understanding of effects magnetic fields towards charged particles can be obtained too. This is because from the experiment that has done, the magnetic bar with the same pole will repel each other, and the magnetic field line bend away from each other. Meanwhile, for the opposite pole of bar magnet, the magnet will attach to each due to strong attractive force, and the magnetic field line are so thicker and attract to each other. So that's it from me. Thank you.